Hello, this is Professor Todd Elliott, and today we're going to have a little lesson on DC offsets. So for our first illustration, I'm using a square wave, and I'm currently using the Uni-T UTG962E function generator. Not that it matters, but anyway. So DC offsets are very common in electronic circuits, and what we mean is that the signal, whether it's a square, triangle, or a sine wave, can have a positive or negative DC offset, meaning it's not biased around zero. And so a simple example would be in a BJT amplifier, where in the actual between the input and output coupling capacitors, we have your sine wave biased on the DC biasing voltages. Okay, but at the output coupling capacitor blocks the DC bias, so you get back a pure sine wave. Okay, so that's just one simple common example. But anyway, okay, so right now on my generator, I have a square wave, 50% duty cycle, a frequency of 1 kilohertz, and I set it up for 5 volts peak to peak, and I'm recording this on my scope. Okay, so you can see that. Okay, and you can see the center ground line there. Okay, all right. Notice that the coupling is on DC. Now let's see what's the effect if I push it to AC coupling. Okay, see, there's no effect because the square wave coming out of the generator is biased, has no offset, it's biased around the center. So right now, whether we're using AC or DC coupling, it doesn't matter, but it will. Okay, so let's say I'm building a counter or something, and I need a clock signal. You don't want to put this into it. Okay, it's going to damage the chips. So what we need to do then, because my generator does not have a TTL output, but it allows you the option to incorporate an offset, which I'm now going to do. So I'm going to put this back to DC coupling. Okay, I'm going to go to my generator, and I'm going to then add in a 2.5 volt DC 2.5 volt DC offset. Just going to readjust my trigger now. Okay, notice that the waveform is now biased around 0 and has a peak voltage of 5. Okay, so this has a positive DC offset, so we shifted it up by 2.5 volts. So let me put that back to 0. So the offset is now gone. Notice it is centered around 0. Okay, just for fun. Okay, we'll put in a minus offset, and you certainly can. There's just no reason why you can't. Okay, so I'm going to set this up for minus 2.5. I'm just gonna adjust it there. Again, just readjust my trigger arrow because now the waveform's down here. Okay, so now I pushed it down 2.5 volts. So this has a negative offset. Change the coupling. Okay, and we're going to change this to AC. Right, move the trigger arrow back up. Okay, so what happens is when you put the oscilloscope, the coupling, on AC, it puts a little picofarad capacitor in series with the with the uh, with the signal, and that capacitor will block any DC. So that's why the signal, it appears to be a straight square wave biased symmetrically around the zero, but it's not. My generator is set for an offset of minus 2.5. Okay, so this is not like a multimeter. Okay, so by default, I always recommend to my students to use DC coupling because it bypasses that input capacitor inside the scope circuitry. And so what you see on the screen is really what you have. So DC coupling is really the safest default setting. If I put the input coupling back to DC, right? And again, I got to move the trigger arrow back down. Okay, now the DC offset is allowed to come through. Okay, all right. So we can do this with a sine wave. Let me go and just get rid of the offset here. 0, 0, clear. Let's change the waveform to sine. Okay, again, just gonna move the trigger arrow back up. Okay, so it's DC coupling. There's no offset, so I can then change my coupling on my scope to AC. There's no offset, so either AC or DC coupling is going to work. Okay, all right. So I'm going to go now and put in a DC offset, and I'm just going to push it like there. Okay, to see, I'm going to put the coupling back to DC. Okay, if we can see something. Okay, and you see as I increase the offset, I'm at a 4-volt offset. That means the imagined center line of the sine wave is shoved upwards 4 volts. Okay, so you see as I reduce it, right? If the offset changes accordingly, and you have to keep always moving the trigger line. Okay, so it's on the waveform there. So that's a 1-volt offset. Okay, and you can see that this is the 0 line. That there's more positive than negative because it's being uplifted by a volt. Okay, and if I dial the offset back to 0, then it's nicely and symmetrical. Okay, so anyway, that's my little quick lesson on DC offsets. I hope it brightened your day, and we'll hopefully catch you soon. All right, cheers, God bless, bye.